Hello class, welcome to today's lesson. Our topic for today is binary compounds. Now, by the end of this lesson, you should be able to discuss the relationship between binary compounds, the composition of binary compounds, and the names of compounds. Now let's come to our main topic for today, binary compounds. Now before we move to binary compounds, one may ask, what is a compound? Now, a compound is a substance which consists of two or more elements chemically combined together in a definite proportion by mass. So let's move to binary compounds. Binary compounds are compounds composed of only two different elements. Now let's look at this. These compounds are formed through the combination of two distinct types of atoms. Now, the elements involved in binary compounds can be metals and non-metals. Now, examples of metals, we have sodium, we have magnesium, we have aluminium, we have potassium. So these are some examples of metals on the periodic table. That's the first 20 elements. So the first 20 elements, some of these metals are found on the periodic table. Now, non-metals. Now, non-metals, examples of non-metals, we have chlorine, we have what? We have sulfur, we have oxygen, then we have more of the examples of the non-metals. So we are saying that binary compounds, they compose of metals and non-metals, or there can be two non-metals. So two different non-metals joined together, they are also composed of these binary compounds. Now let's move on. So there are two main types of compounds. We have one, we have types of compounds. We have ionic compounds. Two, we have covalent compounds. So these are the two types of compounds. We have ionic compounds and covalent compounds. So let's take these types one by one. Okay, so let's talk about ionic compounds. What are ionic compounds? Ionic compounds are compounds composed of two elements. Now these two elements are metals and non-metals. These compounds are formed through ionic bonding. They are formed through what? Ionic bonding. Now, what are ionic bonding? Ionic bonds or ionic bonding is a type of bond formed by the complete transfer of electrons from one atom to another. Now, we have what we call the metals. So these metals, they donate electrons to form positively charged ions. So they are going to donate. So they donate electrons to form positively charged ions called cations. Then the non-metals, will accept electrons. So these are for the metals. So these are for the metals. Then the non-metals will accept electrons to form negative charged ions called the anions. The resulting oppositively charged ions are held together by what? By electrostatic force of attraction. So they have strong electrostatic force of attraction due to the positive and the negative charged ions. Now, let's talk about the properties of ionic compounds. After we will talk about the formation of ionic compounds. So let's talk about the properties of ionic compounds. One, they have high melting point. They have high melting point. They also have high boiling point. They are hard but brittle. They are hard but brittle. Now, when you say they are hard but brittle, it means even though they are hard, but they can break easily. So that is, they are hard and brittle. They are often soluble in polar solvent, when we talk about polar solvent, we are talking about water. So example is water. Then they conduct electricity when in molten state or when in a solution. Then they are insoluble in non-polar, or so the non-polar, they are the organic solvent. Then they are usually hard crystalline solids. So they are hard crystalline solids. So let's talk about examples of ionic compounds, and we talk about the bonding of these ionic compounds. So examples of ionic compounds. So now we are saying that ionic compounds, they compose of metals and non-metals. Sodium, examples of ionic compounds. So we can talk of sodium chloride. You have magnesium chloride. Now, don't worry, we will talk about how sodium chloride, magnesium chloride, or we will talk about how these are formed. So we'll talk about the formation, so don't worry. So these are just the examples of ionic compounds. We can talk about potassium oxide, calcium sulfide. So 1, 2, 3, 4, 5. We can also talk about sodium oxide. Now, we are saying that ionic compounds, they compose of two elements, and that is what these metals and the non-metals. Always the metals are written first and the non-metals are written at the last. So don't worry, we'll talk about how all these are formed. So let's talk about their formation. Let's talk about their formation. So that is the ionic bonding. We will talk about their ionic bonding. So let's talk about chemical bonding. So Chemical bonding is a force that holds ions, molecules, and atoms together. So we will talk about the ionic compounds, how ionic compounds are formed. Now, look at this. Now, a bond is formed so that each atom acquires a stable electronic configuration similar to that of noble gas electronic configuration. Now, what are noble gases? Now, this means that whenever a bond is formed, the main aim of this bond forming is that they want to achieve a stable electronic configuration, same as noble gases. Now, what are noble gases? Now, these noble gases, they are gases that are already stable. Now, these are all stable. So, examples of a noble gas is one, we have helium, which is having number 2. We have 2 neon, which is what 10. We have argon, 18. So these are all stable. So electronic configuration of 2 is stable, 2 8 is stable, 2 8 8 is also stable. So these are examples of noble gases. So for this bonding, their main aim is to achieve stability. And for stability, elements which are already stable, examples are noble gases. So we want all these elements or compounds to achieve stability. All right. So let's take these ionic compounds. So we are starting with ionic compounds. Now we said ionic compounds, they compose of metals and non-metals. And example of a metal is sodium. And example of a non-metal is what? Chlorine. Yeah. Now, first of all, we have to know the symbol for sodium. Sodium is Na. Chlorine is Cl. So sodium and chlorine. Now, what is the electronic configuration of sodium? Sodium is element number what? 11. So it's element number 11. This is sodium. So we have the electronic configuration of sodium is 281. So this is the normal electronic configuration for sodium. Now, let's come here for chlorine. Chlorine is element number 17. What is the electronic configuration of chlorine? That is 287. So this is the electronic configuration of chlorine. This is the electronic configuration of sodium. Now, we will have to draw the normal electronic configuration for sodium. Then we draw the normal electronic configuration for chlorine. So we have first shell takes how many? 2. We have 8. So this is 2. First one is 2. Second one is 8. And the last one is what? Is 1. And the last one is 1. Next one is, so this is the normal sodium. This is the normal sodium. Then we have chlorine, which is first shell taking 1, 2. Second is 1, 2, 2, 1, 2, and 1, 2. Then the last one is 8. 1, 2, sorry, 7. 1, 2, 1, 2. So this is 1, 2, 4, and 6. The last one here. So this is our normal chlorine. This is our normal chlorine. Now this is before they are bonding, and this one will be after they have bonded. So now, since sodium is a metal and chlorine is a non-metal, sodium is donating how many? Sodium is donating 1. Sodium is donating 1 to, like this. Sodium is donating 1. So it is losing the valence shell, the last valence electron, which is 1, to chlorine. Now chlorine will now accept the 1. Are you getting it? Sodium is losing 1. Now that's why we said the metals, they what? They donate their electrons. That's the outermost electron. They donate their outermost electron to form a positive charged ion known as what? A cation ion. Then the non-metals will now accept. So when you accept, you are going to get a charge of what? Of negative. So you are accepting. Now let's move on. Now when sodium donates 1 to chlorine, it will be left with 2, 8. So we are going to draw for 2 and 8. So 2 here is what? 8. This now will be Na plus. Now why is it Na plus? Because it has what? It has donate the 1. So you are going to get sodium 2, 8, 2, 8. So this is sodium ion. Sodium ion, which is a positively charged. Then the chlorine will now accept the 1. So to be what? 288. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So 2, 8, then 8. So this is Cl. So it accepted 1. So you're going to get 2, 8, 8. So this is sodium ion and chlorine ion. Okay, so you can see that this my sodium, this is sodium atom, this is sodium ion. So my sodium atom became sodium ion, then my chlorine atom became what? Chlorine ion. So this is how our ionic bond or ionic compounds are formed. Now, let me give you another example. Let's do another example. Don't worry, I will show you how we are going to name these compounds. So we will do the naming later. But this is how they are formed, their formation. So let's take magnesium, and oxygen. Now, let me make this clear. In order for you to know how these are formed, first of all, you have to know magnesium on the periodic table, oxygen on the periodic table, their element number, their number. So magnesium on the periodic table is what? Having an atomic number of what? 12. Magnesium is 12. And oxygen here is what? 8. Are you getting it? Now, this is magnesium. Now, the next thing is you have to know the electronic configuration of magnesium. What is the electronic configuration of magnesium? Now, magnesium's electronic configuration is 2, 8, 2. This is 12. First shell takes 2, second shell takes 8, next one, it has left with what? 2. Next is oxygen. Oxygen electronic configuration 2, first shell will take 2. Now, how many more is needed to obtain 8? That is 6. Don't forget, oxygen is not stable. Magnesium is also not stable. Now, we are saying that in order for these to form, they should achieve a stability, what we call stability, a stable electronic configuration. So this electronic configuration is not stable. In order for it to be stable, this has to donate it to. In order for this one to be stable, it has to what? Accept these two to become stable or to achieve a stability. Now, the next thing is we what? We draw the normal electronic configuration for magnesium. So the normal electronic configuration for magnesium is 2H2. So we draw for 2H2. So this is 2, 8, then 2. So this is my magnesium. Now, when you are drawing, all these are not needed, but you just do it somewhere, then it will guide you to draw this. Then oxygen is what? 2, 6. So I'll draw for 2, then I'll draw for 6. 1, 2, 1, 2, 1, 2. So this will donate H2 to this. So this is my oxygen. This is my oxygen. So this is magnesium atom, oxygen atom. Next one is we are going to what? We are going to draw our magnesium ion. Now, magnesium will lose how many? It will lose the last valence electron, which is 2. So magnesium will donate 2 to oxygen. So when it donates 2, it will be left with only 2, 8. So we will draw for only 2, 8. So 2, then 8. 1, 2, 3, 4, 5, 6, 7, 8. So my magnesium here. Now, how many did magnesium donated? Magnesium donated 2. So we will write 2 plus. Then oxygen will now accept the 2. So when oxygen accepts the 2, it is going to be 2, 8. So 1, 2, then 1, 2, 1, 2, 1, 2, 1, 2. So it will be O2 minus. So oxygen accepted 2. So it's 2 minus. So here will be 2, 8 for magnesium ion. Here will also be 2, 8 for oxygen ion. So from this magnesium atom became magnesium ion, then oxygen atom became oxygen ion. Now let's do another example. Now don't forget we are saying ionic compounds, they contain a metal and a non-metal. So it is composed of only metals and non-metals. So let's do another example. This is example 2. Example 3. Let's take potassium. Potassium and chlorine, potassium, and chlorine. So let's do for potassium and chlorine. Now, potassium is what? K. The symbol is K. Chlorine, the symbol is Cl. Now, potassium, element number 19 on the periodic table. Chlorine is 17 like this. So 19 and 17. Now, what is the electronic configuration for potassium? That is 2. First shell takes 2. Second shell takes how many? 8. 8 plus 2 is 10. How many more? 9. Next shell takes 8. What is left? 1. So 2881. That is for potassium. Chlorine. First shell takes 2, 8, and 7 for 17. Now, don't forget for electronic configuration, first shell takes 2, 8, 8, 8, 8, 8. So if the first shell takes 8, the second shell should also take 8. If it is more than 8, you give a 8 to this, then the next number will be on the next shell. So if it is also less, then you leave it, you write that number. So let's draw for the normal potassium atom. So for the normal potassium atom, you're going to get 2881. So we will draw for 2881. So 2, 8, 2, 8. Next one is 8. And the next one is just 1. It's 1. So this is potassium atom. Potassium atom. Next one is chlorine. Chlorine. So 2A7. We draw for 2A7. So this is 2. This is 8. Then 7. 1, 2, 3, 4, 5, 6, and 7 like this. So this is 4 chlorine. So this is 2881. This is 2A7 chlorine. So you can just write it under 2881. This is 287. Because I was using this to explain, that's why I wrote it for you. So after you write it at the down there. Now that is, we are now to what? To draw for the potassium ion. So now potassium will donate 1 to chlorine. So we are going to get 288. So you draw for 288. So 2, 8, then 8. So 2, 8, 8. Then write potassium. Now, how many did potassium donated? That is 1. So we just write plus. So plus. So plus 1. But we just write the plus. We don't add the 1. Or we don't attach the 1. Next one is chlorine. So chlorine will now accept 1. So when chlorine accepts 1, we are going to get 288. Chlorine is accepting 1. So we are going to get 288. So we draw for 288. So 2, 8, 288. So 2, 8. This is now chlorine ion. This is potassium ion. Now, this is for potassium and chlorine. I said, don't forget, I will teach you how we are going to name this as potassium chloride. So the names. Now, let's move to. Now, let me give you example. Let me give you example so that you solve it. Then provide the answers. So you solve and provide the answer. So assignment. So you draw the bond formation of the following. Let me make it clear for using their electronic configuration. So one, let me use potassium and oxygen. Two, sodium and oxygen. Three, aluminium and chlorine. So try your hands on this. Try your hands on this. In our next lesson, we will discuss it. Thank you all for joining my lesson. See you in our next class.